Hello, my name is Russell Goodall and I work at the Materials Science and Engineering Department at the University of Sheffield. Today I'd like to show you a few demonstrations about metals and perhaps some of the slightly more unusual properties that they have. Well, you probably know about the change of size and shape in materials that can happen when you change their temperature. A very clear example of this comes about when we cast materials, when we take something that's liquid and turn it into a solid with a particular shape. So I can demonstrate that here with this special alloy. This is a mixture of bismuth, indium and tin and has a low melting point, so I can melt it in hot water. I can cast this because it's liquid. I can pour it out into this mould here. As that metal cools and solidifies, as you might expect, it'll get smaller, it'll contract, and you might see a little dimple forming in the top. I've also got some models here of all sorts of different structures that solid materials can adopt. And the two that I'm talking about at the moment, this is the first one where we have a cube and then atoms in the center of the faces. And this is the second form where we have once again a cube but an atom sitting right in the middle. There is some very important effects that come from this, particularly in the case of steel, which is mostly iron, a very, very important material and one with a long history here in Sheffield. Iron undergoes a change whilst it's solid between one of these forms and the other, around about 912 degrees. And these two forms don't actually occupy the same space. One is slightly more compact than the other. So when we go through that transition, there's a sudden shape and volume change that occurs in steel. And I'm going to demonstrate that for you here with this wire demonstration. Now, there's a wire strung out here that may be a little bit difficult to see. So I'm going to hang Spiderman on there because he's used to hanging around in the air. And this wire is connected to an electrical supply. I can send electric current along that wire, and as you probably know, that will cause it to heat up. That's the principle of an electrical heater. Now initially, as it heats, Spiderman is dropping down because the wire is getting longer, doing thermal expansion, and therefore it's sagging. But I'm going to keep turning up the heat to try and get it nice and hot. It's sort of starting to glow, and I really want it to be as glowing hot as I can manage. I need it to be above 912 degrees to see the effect that we're after. So that's glowing nicely now. What I'm going to do is I'm going to turn off the power, and we'll watch what happens to Spiderman. So the power goes off sharply, and then Spiderman goes up, little dip, and then carries up back on. This kind of effect is very, very important, because if we take iron, which that wire was made from, and add carbon to it, we get steel. And steel, as I said, is a very important and widely used material. The carbon sits in between the atoms in these structures, and because they're different structures, they don't have the same amount of space. And by how we cool down steel when we make it, we can change its properties and behavior. So what I have here, I have a couple of examples of the same steel that's been treated in different ways. And I will give it a bend. Oh, it's rather difficult. That's quite a strong material, but you can see that I have managed to cause it to bend. That's a nice combination of properties. It's strong, so it resists change of shape, but it's also ductile. So when it does change shape, it can do so without suddenly failing. I'll try the same thing with this, and it snaps really, really easily. It's very, very brittle. So much less desirable behavior for many applications, although there could be some instances where we want something that's very, very hard, as that steel is. So hopefully what these demonstrations show is that there's a lot we can do with metals and materials in general by changing how we process them, changing what we do with them. And that understanding and using it to develop new materials to do things better is exactly what material science and engineering is about.